This lesson is finding the least squares regression line using a TI-84 graphing calculator. This lesson assumes that you know how to enter data into a graphing calculator and graph a scatter plot. On the board, I have the data of 10 states, including Wisconsin, that are geographically close, and I have the SAT verbal and the SAT math score. I would like to know if you knew the SAT verbal score in this area, could you predict the math score? So we will get out our graphing calculator, and if we go into Stat and Edit, you can see that I have already entered the data into List 1 and List 2. If we go up to Y equals, you should always check to see if there are any equations in here left over from a previous lesson. You should always clear that out. Then if we go into Window, I have picked an appropriate window looking at the minimum and maximum values of my data, and I picked from 550 to 610 with tick marks at 10. Now above the Y equal, we're going to go into the stat plot. We're going to take plot number 1. We first of all need to turn it on. I have a scatter plot. The X list is in list 1, my explanatory variable. My Y list is in list 2, that is my response variable. And again, you can pick either mark, the first or the second, whatever your preference. So we're going to graph those 10 points. And you can see that a good graph is going to use most of the screen, not condense all the points into one corner. So I have a good scatter plot. The next thing I need to do is to get my regression line. So if I go back into my stat button, I'm going to go over to calculate, and the linear regression that I want is in the form of a plus bx. So I want to go down to number 8. That is a linear regression in the form of a plus bx. So I'll select that. And I want list 1. Again, that is a second and a 1 key. Comma is above the 7 key. And list 2, again, a second and a 2 key. This will give me my linear regression. We also see the correlation, about approximately 9/10 would be a very strong positive correlation, and our coefficient of determination. Looking at this data, we then could write our regression line as y hat equals -8 and 725 thousandths plus 1 and 26 thousandths x. Now, looking at the regression line, we can see that the slope is just slightly more than 1, which should tell us that the average verbal and math scores are approximately the same. Going back to our calculator, I could then go into y equals and type that equation into y1 so I could look at the graph. There are a couple other ways to do that. If I do second entry and get my last command up, if I add one more argument, I can have my calculator automatically paste the regression line into y1. So I have to add a comma, again, above the 7 key. And I want to say y1. I want the calculator to paste the regression line into y1. So you have to go into the key that is vars, which stands for variables. And we're going to go into vars and over to y variables. And we're going to take function and we're going to take y1. So when we do an enter, it looks much the same, but if I go into my y equal, it has pasted the line into y1, and not only pasted it, but it has pasted it with all the decimal places. If I go into the graph, I can look at my regression line to see how well it fits. Now, if I wanted to know if the score was 590, what would be the math score? I could go into my table option. I could type in 590. I could go over to my table, and if my verbal score was 590, my regression line would predict that my math score would be approximately 597. So this is how you get a regression line um, given two sets of data and use your regression line to make predictions.